So how is it possible for minerals to change and crystals to change if the rock stays a solid? There's a few different ways this can happen. The first is recrystallization, right? This means that the mineral composition doesn't necessarily change. Instead, the size of the crystals change, right? So maybe you start with really, really tiny crystals of quartz, and under metamorphism, those tiny crystals of quartz are going to recrystallize into new, larger quartz grains. So again, the composition doesn't necessarily have to change, but the crystals are recrystallized into a new, larger crystal. So that's what we call recrystallization. The second process that can happen is when the composition does change. The minerals do change. Right? So for example, you could start with a protolith that is made up of clay and quartz, and the chemical bonds within the crystals break, the atoms reorient themselves, they create new bonds, creating new minerals, and you might end up with a metamorphic rock with totally new minerals like quartz, garnet, and mica. Right? So old minerals break down to form new minerals. Again, this is all happening when the rock is a solid. Right? And the new minerals that form, those are going to be the minerals that are more stable in the new conditions. Right? So if the rock undergoes intense heat and pressure, the minerals that form are going to be those minerals that are more stable at those intense heat and pressure. Right? The next process that can happen is a pressure solution. And this one I think is pretty cool. So this one, again, there's no melting, but the mineral grains actually start to dissolve at their boundaries where they're pushing together under that intense pressure. And the ions that form, right, the atoms that are charged that form due to that dissolution, when the mineral grains start to dissolve, those ions start to travel kind of like a really thin film of water to areas of lower pressure. Right, so you can start, for example, with spherical grains that are all touching each other. And when you push those spherical grains together, the edges of those spherical grains are going to dissolve. Those ions in solution are going to migrate to areas of lower pressure. And so you're going to get this layered effect of elliptical grains in your new metamorphic rock. Right, the final metamorphic we're going to talk about, metamorphic process we're going to talk about is plastic deformation. Right here, once again, you can start with spherical grains, end up with elliptical grains, but now instead of anything dissolving, now those spherical grains are getting so hot, they start to behave like a plastic, meaning they can squish into elliptical grains or oval grains, right? So again, you start with spherical and you end up with kind of this linear pattern of these elliptical grains due to plastic deformation. All right, so all of these processes allow for what we call polymorphs or phase changes. This means that several rocks or several minerals can all have the exact same composition, right? They're made up of the same elements, but those elements are bonded together in different arrangements. So they're different minerals, they're different rocks. And how those different elements, or how those same elements bond together in different arrangements all depends on the pressure and temperature. So for example, the three different minerals, andalusite, kyanite, and sillimanite, they all have the exact same composition. They are all Al2SiO5, aluminum, 2, silica, oxygen, 5. Every single one of them. But those elements are bonded in different arrangements and different shapes based on the pressure and temperature at which they're formed. So andalusite, that is formed at low temperature, low pressure. Kyanite, which is a beautiful blue color, it's one of my favorite minerals, is formed at low temperature, high pressure. Sillimanite, formed at high pressure, high temperature, right? So we call those polymorphs, minerals with the exact same composition, but they look different because the chemical bonds are different shapes.